Welcome, everyone. Thank you for joining us on today's live webinar on the role of packet capture in the design of zero trust hybrid cloud deployments. My name is Kashif, Senior Director of Marketing, and I will be your moderator today. We also have an executive speaker with us in Ron Nevo, who is Chief Technology Officer at cPacket Networks. Today's webinar is going to focus on the why and when your organization embarks on a zero trust journey and the need to consider network packet capture as a critical part of your technology and security strategy. So before we dive into the details of zero trust, let's review some latest stats around today's threat landscape. This slide here is a great illustration which shows us that 2022 was a continuation of the trends of rising cost and rising severity of security breaches. The three key data points here are the first one is that the average cost of a data breach in the US in 2022 was $9.4 million on average. That represents an increase of 13% year over year compared to 2021. It takes an organization an average of 277 days to detect that a breach has occurred in its environment. And once that detection happens, it takes an organization another 90 days on average to resolve that breach and bring the systems, the environment back to the normal level, before the breach happened. So the key takeaway is that things are not getting better. Instead, they are getting worse compared to the last few years. Next slide, please. Starting off with a brief history here, zero trust was introduced with the goal of reducing the number and severity of security breaches and limiting the overall impact of damages associated with the security breaches. The term zero trust was first introduced in 2010 by Forrester research analyst John Kinderweg, who presented the idea that an organization should not extend trust to anything inside or outside its parameters. From 2010 onwards, zero trust gained traction, especially in the private sector. And in 2018, the NIST, which is the National Institute of Standards and Technology, it's a federal agency under the U.S. Department of Commerce, released a special publication, SP 800207, on zero trust architecture, which offered some basic guidelines on the core components of zero trust. This documentation, SP 800207, was further revised in 2020. As zero trust strategies were starting to take hold in the private sector, the US federal government got more involved in the past few years, and then they introduced their own efforts in 2021 to move zero trust security in federal government agencies. In 2021, President Joe Biden issued an executive order number 14028 to improve the nation's cybersecurity posture and strengthen the federal government's critical infrastructure cyber defenses. This order also included specific steps to advance towards zero trust architecture within the government agencies. These actions to move towards zero trust by the US government and other government entities worldwide has accelerated zero trust adoption. And according to Okta's latest report, the State of Zero Trust Security 2022, 72% of government organizations surveyed had a defined zero trust security initiative in place, compared to 55% of global non-government organizations. So moving on towards the main content of this webinar here, Ron, we have talked about the key data points here, about the data breaches. We have gone quickly over the evolution of zero trust. What is your take on zero trust and how is it different from legacy systems?
Yeah, I think, thanks, Kash, for the introduction and the question. People use the name zero trust to really contrast from the more traditional way of thinking about security that evolved in the 90s, where you can think about it as a castle and moat type. There was the notion that your office is your castle, and you can build a moat around it and keep all the back up. This is where people introduce a firewall, DMZs, and the idea was that we can protect our assets by building really strong defenses on the outside. What happened in the early 2000s, and I think this is where the origins of the zero trust approach evolved, that it was that on one hand, we had laptops and Wi-Fi, and people were able to work in any coffee spot, in any coffee shop with hotspots or cellular. On the other hand, cloud computing started showing up. So all this notion of the 90s where you had a desktop and maybe you had dial up with a VPN, and it was very clear it was inside your organization, and who was outside the organization based on the location started calling. So that's where this notion where it's not enough to protect her, even if someone is inside your organization physically, that does not mean that you can trust explicitly. So this is where the approaches, and I think we're converging to this terminology of zero trust, which is a type of a mindset that says it doesn't matter where the asset or the person or the device is, you can't implicitly or explicitly trust the person, and then you have to protect against that anywhere you are. For me, I think there are kind of two fundamental tenets describe zero trust or imply the trust is. We can see the slide, I think, just to summarize it. One is trust nothing. If someone is inside your organization physically, doesn't mean that you can trust him, or the device is center, it does him. And the other one is really something that doesn't get enough attention, which is you have to be unexpected. There are people that try and cause data breach are very creative. They keep coming up with new ideas how to break the defenses, and you have to prepare yourself at any given point in time that something might happen, and whatever notions that we had, whatever Zwick or Bro has today, 3,000 different known attacks can protect against. There's always going to be the 1,001 and 3,002. So these two fundamental things, which is one is verify anyone that talks to you that's really who is, who says he is, and the other that always expecting that you didn't expect are the fundamental things that trust preaches. I think zero trust is a mindset or a journey that encounters multiple policies and technologies and architecture, not one single thing. But if we take out of this discussion these two tenets, I think it will help people as they evolve their security organization to kind of embed the spirit of what zero trust brings. It's one of another industry that kind of adopted this notion is the aviation industry, right? And if you look on the aviation industry over time, and you look on the number of deaths caused in the aviation industry, starting from the beginning, from 1918 to now, one interesting thing that you can see is that though the total number of people flying and hours flying, any other measurements of busy load on the airline industry, aviation industry is going up. I heard that there is a video. So let me turn off the video and see, and let me know if it's better. Even though the aviation industry is, there are more people flying, more is being flown, but the number of accidents or the number of deaths is going down. And one of the big inventions around that was, I think, the black box. I think that's where the aviation industry understood that however we want to plan and build our planes safe, there's always going to be an incident that we didn't expect. And the only way we can improve is if and when an incident or accident happens, we have all the relevant data that during the time, so that we're able to protect ourselves from the next time. So again, if you think about it, yes, one thing is trust nothing, but the other thing is because you have to expect the unexpected. The only way we can build something that is more resilient and be able to bend the curve that we're seeing today of cybersecurity is after an incident, after a data breach, we have all the relevant data such that we're able to be prepared for the next time. So these are kind of two big tenets that we need to remember. One is trust nothing. The other one is expect the unexpected. And the way to treat with unexpected is really the ability to understand after the incident what happened, make sure that we uh, uh, from that occurring in the next time.
Thank you, Ron. We're talking about zero trust, but then we're also saying what we're saying today, Ron, is a shift towards the use of hybrid cloud deployments. Can you talk about what does packet capture mean in a hybrid cloud deployment?
Yeah, sure. I think hybrid deployments is an interesting challenge. We talked about the challenges of protecting our organization without perimeter. Obviously, as things move to a hybrid cloud, things are much more complex. Applications, they're not no longer inside the data center or on the cloud only. In reality, is today maybe 60% in the data center, 40% overall in the IT industry in the US. 60% the enterprise workload in the data center, 40% in the cloud. Expect to see transition to 40-60. Percent is in the data center, 60% is in the cloud. But the most important thing to understand is that if you think about a single application, it's not either here or there, but rather it's both. Every application that we deliver today, every large-scale application today, will have components that are running in the data center and some components that run in a cloud. If you think about a website or a bank, and if you log today to one of them, there are somewhere like there are 100 different applications at the background of your homepage, whether they go to your account or Visa or Visa account, serving you offers. So in the background, you can think about 100 different applications and authentication services. And these are spread across the data cloud. We don't think one of the explains why simple protection of the perimeter is not enough. We really have to protect the different locations and the different applications where they are. And the other side is that is important to how do I capture what was going on across this complex environment. And the way to think about it is really you have to capture packets, and then maybe we'll talk about later why I'm saying packets versus something else. But you have to be able to capture them anywhere, anytime, such that if and when you have a data breach, you're able to reconstruct what happened, and you're able to reconstruct it whether it happened in your center, or whether it happened in Azure or GCP or AWS or in a colo or in a brand, right? The environment of an enterprise today consists of these, and there are a few locations or type of locations that have exist. Just being able to capture what happened, understand what happened, and do that across a very complex architecture. And deployment is one of the key challenges as we move as organizations and companies embrace zero trust and evolve their customer and security strategy to have zero trust. across the station.
Thank you, Ron. Ron, you also mentioned that packet data is very important for zero trust implementation. Can you expand on this point and why system logs and application logs aren't enough?
Yeah, absolutely. I think it is one of the points that we want people to take. Logs are absolutely important, whether it's system logs or application logs or Zik logs or any on firewall logs. Quite a few logs in your system today. The point is that logs really capture what is expected. So, if we look at a security probe that knows about 3,000 different attacks, that's 3,000 different attacks that it's going to. If a developer is writing that he knows might cause a problem, then he will put a log entry such that if this incident happens, you will see that. Uh, However, anyone that runs a big network knows that the things that really take us are the things that we don't expect. And actually, instead of security, many prefer to use that simple software, not even a bug, but it happens in things that in a normal operation of a network. One of the examples that I'm using many times is that we had a customer that often a set of his users couldn't connect to one of the services, and they looked at the logs. Actually, they looked at the packet capture from the user side, and they saw that the user is starting TCP connection. When he was trying to establish an HTTPS connection, the check was rejected. And they looked at the file, there was nothing there. They looked at the load balancer, there was nothing there. They looked at the application servers, there was there actually. They started the application server. The application server didn't see anything. Once they actually ran packet capture across all these different locations, what they found out was that this was a software out their load balancer that decided to check one of the fields in the load message. And if it didn't like the SNI, it responded with a reset. That's nothing that anyone expects. That's again, something that the software engineer that delivered the software for that load balancer, so it's a good idea. Made it sure, and obviously caused quite a lot of pain for the customer. But everyone was thinking that we're doing the right thing. So the logs were empty. So that's an example where you are trying to root cause what happened, understand what happened. The only way for us to really happen was to view the packet captures in every single location across the value chain, all the way user, through the firewall, through the load balancer, through the application server. And you can imagine a much more complex path if some of the services were actually running out versus the data center. So if you remember, again, there are two sets of zero trust. One is trust nothing, the other one is the expected. So when we run a analysis of something that happened that we didn't expect, the only way for us, practically speaking, is to see the packets.
Got it, Ron. And moving on to the next question, we have discussed the general requirements. When implementing complete zero trust framework, including the need for a comprehensive forensic solution. Like you talked about the aviation industry black box. Uh, can you
Right.
explain how cPacket can provide the building blocks of a successful zero trust approach and deployment strategy?
Yeah, no, it's a great question. So one of the things that actually I saw one of the comments in the chat about sending the packets to an NDR tool, and it's absolutely something that you have to do. I think the NDR tools fall most part to the category of looking for incidents in real time, things that they know about. Some are trying to use more of AI. so they know maybe more. So packets have to be fed both, right? Packets have to be fed into NDR tools. That's an absolute requirement. At the same time, you want to capture them such that if the NDR tool missed them, you'll be able to understand what happened retroactively and make sure that your NDR tool is up to date the next time around. So the specific things about cPacket in this regard is one is this eye chart. So I think in the data center, people have been doing packet capture for quite a while. It's certainly not trivial. I think the technology, being able to capture packets at 100 gigabit per second is less trivial, and cPacket has a solution for it. But really, they have an eye chart here is to make the point that when we are going to a cloud deployment, whether it's Azure or GCP or AWS, there are quite a lot of different approaches and technologies that us to get packets, and they're quite different, and the requirements and the infrastructure deployment are quite varied. You really, assuming that you open multi-clouds, or you might have environments in the cloud in a single cloud, you really want to work with someone that has the ability to support the different deployment options. So I'm not intending to go out for these six. There are actually many more of these deployments. What is important is as you run and deploying things in the cloud to real different cloud providers provide things that are a little different and different requirements deployment of deployment have you have different options to be able to and work with a vendor that allows you to do that. For that perspective, if I just go through what cPacket has built over the last years, is really a whole set of products, starting from the ability to access the packets in the data center, which requires being able to go all the way from 10 gigabit per second to 100. We're looking now at the 400, even 800 gigabit per second. Being able to terminate optical taps and spans. At the same time, have the exact same technology in the cloud as a virtual environment. And when I say the same technology, it means that I'm able to not only receive the packets, but I'm able to feed multiple at the same time with the same. We have customers that have between 7 and 12 different security tools to our packet brokers, and you need to be able to do that on-prem and the cloud. So the first level, it's a packet. We're referring to them as CVU, is the set of packet brokers. On top of that, you want the ability to capture packets, such that when you run forensics, you're able to look at the packet wherever you capture them, whether it's inside your data center or branch, and the virtual devices in the cloud. Again, a little different deployment options in different clouds, but for the most part, this becomes more unified. You want the packets have to be delivered in a format that we're used to. For the most part, this is a pickup format. And then the most important thing up is really single pane of glass. It's in the cPacket product, we refer to it as clear. It's the ability to run a single software, can be running in the cloud, can be in the data center, but it's able to access your packet capture across your value chain, across your service chain, and being able to show you the unified capture in one location. So this is kind of, I would say, if you go back and think about the high-level requirements that we out at the beginning, which is being able to capture packets anywhere, anytime, and being able to show it in a single dashboard or a single unified capture. This is the implementation that cPacket uses to deliver for that vision, or I would say these fundamental requirements of evolving evolving your strategy to zero trust.
So, Ron, there is one question which came from the audience. I think this is regarding the zero trust deployment. So the question is, how
Mhm.
do you solve that same problem in the cloud, versus in the data center?
Mhm. Yeah, so the cloud, I'll maybe spend a little bit on the technology there. The different cloud providers provide different approaches that allow you to get access to packets. Uh, the two fundamental approaches, one is they refer to as virtual, which allows you to create packet mirroring on every NIC or NIC that you select. That means that every endpoint takes the packets and multiply them and sends a copy of the packets to a device that is like a packet broker in the data center. In our case, it's the CVUV, virtual CVU. Uh, and from the CVUV, you can send it to a capture device and or to an ADR device. If you have a single device that you need to feed, then just take this mirroring option from every NIC and you forward all of them to the same location. Um, this example again, I don't want to go too details into the eye chart here, but the left hand side describe this approach. The packet mirroring is happening on every single NIC, or maybe you can use diagram to see that where the packet mirroring happens on every single. Another approach that cloud providers provide and support is the ability to sit on the transit gateway or the gateway to the which allows you to duplicate the packets only to a VNet or a VPC. In which way you get the packets as they travel towards the VPC or the VNet. This is more like on the right hand side there. You get the aggregate of the packets. You're getting every single packet, but you get the access of the packets as they travel. That's actually has quite a lot of advantages. It's similar to the way we used to get packets in the data center. Um, and again, there are different requirements, different pros and cons, and user packet supports all of these different. It requires a more detailed discussion about exactly what the requirements are, and we can support it. The important part is that you still want to be able to capture the packet without having to deploy agents on every single device, on every single instance in your cloud. Good news is that today on all three clouds, GCP, Azure, and AWS, you have the option to do that.
Ron, there is another question from the audience. Is the mirroring truly available on the load balancer as well as endpoints?
Yeah, so it's not quite on the load balancers. There are different options in Azure. We're using so they're not really available on the load balancer. These are special types in Azure and in AWS. Uh, and GCP does not have the load balancer that we showed in the picture is really useful to scale the throughput of capture. So either to be able to scale the capture to any size, this is a load balancer. But it's not really on the loader, but it's on the gateway towards the VPC.
Got it, Ron. If you can bring up the next question, please. So there's a question coming in. So, Ron, you can see the question. Can you discuss the difference between a robust solution versus a resilient solution, and how
Sure.
packet
Yeah,
data capture enables building a cybersecurity solution which is resilient to increased attacks?
it's a great question. I would say the difference between robustness and resilience is when you build a robust system, it's a system that's supposed to be able to stay running when it's being hit. And in general, cloud deployments are a great example where you have, multiple availability zones and a lot of duplication and redundancy. So if one system goes down, another system goes back. The issue comes up when everything goes everything goes down. Right? If you have 7 lanes, but you have an accident in the middle of 7 lanes, it doesn't mean that you have 7 lanes. All lanes are stopped. And at that point, you're asking yourself how resilient your system is, which means how quickly you can recover from this outage, from this problem. What robustness allows, being able to protect against incidents. The spirit of expect the unexpected, your strategy have to involve, okay, somebody did manage to break my defenses and did manage to go around. So how quickly can we recover from this event? And being able to understand what was going on is important part in the ability to jump back. And as you need to deliver 5 nines reliability, it's not enough to build a robust system. You also have to be able to build a resilient system. Yes, there's going to be some outages, there are going to be some data breaches, there are going to be some cybersecurity incidents, and as an organization to quickly figure out what happened from that quickly.
Ron, another question here from the audience. Yeah, how do you get access to the network packets in Azure when they don't have a VPC mirroring functionality like AWS has?
Sure. It requires a much longer discussion. I would say the short that is we're taking advantage of UDR, the user-defined routing feature of Azure, and we're able to forward the packets to our tools and essentially create a hairpin where we get a copy and forward the packets to the destination with effectively minimal disruption or no disruption beyond the hairpin that we have to perform in order to copy of the packets. Again, there are many more technical details that I'll be more than happy to spend the time and explain in specific in different deployments. We have again, different requirements, before the firewall, after the firewall, and so forth, that change some things. This is, I would say, the shorthand of how we're able to the package.
Sure, Ron. Another question here from Cesar. Do you capture the packet before encryption or after encryption?
Yeah, that's a great question. So we are agnostic to whether the packets are encrypted or I would say so. Really, if you have an inline device that is able to decrypt the packet or is decrypting the packets, and you can create the hairpin. Sure, it will be a hairpin in AWS. It's either the gateway or the you get them decrypted or encrypted. Don't really change that. I can say that 99.4 deployments, the traffic that is going through us is encrypted because this data is being captured on devices and it's sensitive. So I don't remember often any customer that today captures decrypted data, even though we are able to do that. I will add that we do have customers that send sensitive data. They are concerned about the payload or the sensitive data, in which case what we do is we encapsulate the payload. So the data itself that is stored are the headers and not the payload, which for the most part allows you to understand what was going on. It's a little different.
And Ron, another question from Josh. I think talking about the cPacket solutions, are our solutions extendable to serverless architecture?
Yes, I think so. The short answer is yes. again, many details. The question is how much of a north south versus packets that you want. The For the most part, we're seeing people, even when they're going to a serverless deployments, they have clear ideas of boundaries between different microservices and or units and or business units. And what they're looking for is for the most part is the transactions between services, and in many cases, microservices will sit on a different VNet. So you can call it north south in a sense, but we are seeing the data there to extend the capture mirroring of the packets all the way to node, something like VPC traffic mirroring. The ability to capture inside the server, if you're looking for inter-container traffic, that becomes much trickier. That this is really, you need to create either an agent or cause an issue opening of the security machine. So while it is possible, we don't have customers that opt for that option. So for today, people are either looking for traffic coming in and out of the machine, a node, and or traffic that's coming in and out of a VNet or VPC.
Thanks, Ron. And I believe we have the last question here. Can you expand a little about what you mean by anti-fragility and how it applies here?
Yeah. And there are some talks that I have, and I think I like the term agility. And this is a term that Nasib Taleb coined, where he said, well, there are systems that are getting weaker at times. But there are systems that actually get stronger. I look at the aviation industry, uh, even though we fly more and more, or not even fly more and more, so that means use the system more and more. But the total number of incidents or down. So something in the aviation industry where the more we use, the more we load the system, the stronger it becomes. And today, if I look, this is kind of your nirvana, right? You want to be able to use your system more, but but stronger and stronger. If you look on cybersecurity today, we obviously, I think you've mentioned at the beginning, Kashif, is that trends are not good. We have more people using the internet more, but number data breaches is going up, the cost is going up, the time to fix them is going up. And I think for us as an industry, it's really about, can we get what the aviation industry has done, and can we work together to become anti. So the more we're going to use, the more we're going to leverage the internet, the more we're going to connect, the more we use it, we're actually going to build a better cybersecurity system. Not only keep the numbers that we see as they are today, but really bend the curve and make our numbers go down. So to me, that's kind of, if we think about principles, yes, trust nothing says, okay, there's a whole set of architecture and policies and technology that I have to put into authentication and so forth. But really, the ability to bend the curve is to figure out what happened once and very quickly make sure it's not happening again and protect against the next thing. I think that's how we can make the cybersecurity, for lack of better word, anti-fragile, right? So such that the curve is going down instead of going up.
And then there is an additional question here. I can take it. That's from Z Collab. Can you share an architecture document around Azure deployment? So Z, we do have, please visit our website. We have, a bunch of collateral around Azure deployments. We have the demo videos, we have application notes, we have technical briefs. So please, go to our website and take a look. And, if you can bring up the QR code there.
Oh, sorry, I think it's on my side. The sharing stopped.
Okay. Um, Let me.
Not sure. Oh, here it's coming. Okay.
Okay, perfect. So for the audience, you can scan the QR codes here. The first one is the literature package. So, you can go in and you can get our content, around zero trust deployments, and you know how cPacket can help you with that. You can also contact us for a demo with one of our experts. You can use the QR code for that. And then we also have a resources page for our government clients and customers, a set of collateral there. So, please scan the QR code for the government resources as well. Yeah, Ron, I think this is it from our side. Uh, a really engaged audience. I know we ran into some challenges here with the audio, but
Yeah, I
feel free.
apologize for that.
Yeah, please reach out to us. On LinkedIn, on our webpage, and we'll be happy to work with you. And Ron, for you, thank you so much for your time today, and sharing your
Oh, thank you,
expertise
Kash.
in trust. And for the audience, again, thank you so much for attending. We will be back soon with our next webinar on November 9th. So stay tuned on that. Thank you again and have a great day.